The Operation System Interconnection or OSI model is a conceptual model created by the International Organization for Standardization which enables diverse communication systems to communicate using a standard protocol in plain English. The OSI provides a standard for different computer systems to be able to communicate with each other. The OSI model can be seen as a universal language for computer networking. It's based on the concepts of splitting up a communication system into 7 abstract layers. Each one is stacked upon the last. The purpose of OSI reference model is to guide technology vendors and developers so the digital communications products and software programs they create can interoperate and to promote a clear framework that describes the function of a networking or telecommunication system that's in use. 7 different layers of the OSI model. The first one is the application layer. Application layer is the highest level of open system providing services directly from the application process. It allows the user to access, retrieve, and manage files in a remote computer. It provides the basis for email forwarding and storage facilities. A few examples of application layer protocols are the Hypertext Transfer Protocol or HTTP, File Transfer Protocol or FTP, Post Office Protocol or POP, Simple Mail Transfer Protocol or SMTP, and Domain Name System or DNS. The next layer is the presentation layer. The presentation layer is also called the syntax layer since it is responsible for maintaining the proper syntax of the data which it either receives and transmits to another layers. Presentation layer format and encrypts data to be sent across the network. Some examples of presentation layer protocols are SSL, HTTP or HTML, FTP, AppleTalk, Filing Protocol or Telnet.
The session layer provides the mechanism for opening, closing, and managing a session between end-user application processes, a semi-permanent dialogue. Communication session consists of requests and response that occur between application. Session layer services are commonly used in application environments that make use of remote procedure. An example of session layer protocol is the OSI protocol suite session layer protocol, also known as X.225 or ISO 8327. In case of connection loss, this protocol may try to recover the connection if connection is not used for a long period. The session layer protocol may close it and reopen it. Transport layer provides transparent transfer of data and between end users, providing reliable data transfer service to the upper layers. The transport layers control the reliability of a given link through flow control, segmentation, and the segmentation and error controls. Some protocols are state and connection oriented. This means that transport layer can keep track of the segments and transmit those that fail. The transport layer also provides the acknowledgement of the successful data transmission and send the next data if no errors occur.
The network layer is the part of the Internet communications process where these connections occur by sending packets of data back and forth between different networks. Anything that has to do with the internet connections takes place at the network layer. This includes setting up the routes for data packets to take, checking to see if a server in another network is up and running, and addressing and receiving IP packets from other networks. This process perhaps the most important, as the vast majority of internet traffic is sent over IP. The primary function of the network layer is to enable different networks to be interconnected. It does this by forwarding packets to network routers, which rely on algorithms to determine the best paths for the data to travel. These paths are known as the virtual circuits. The network layer relies on the Internet Control Message Protocol for error control handling and diagnostics to ensure packets are sent correctly. Quality of service is also available to permit certain traffic to be prioritized over the traffic. The network layer can support either connection-oriented or connection-less networks, but such a network data transmission can only be one type and not both. The data link layer. It is very similar to the network layer, except the data link layer facilitates data transfer between two devices on the same network. The data link layer takes packets from the network layer and breaks them into smaller pieces called frames. Like the network layer, the data link layer is also responsible for flow control and error control in the inter-network communication. The data link layer takes the data bits and frames and create packets of the data to guarantee reliable transmission. This layer adds source and destination addresses to the data stream as well as the information to detect and control transmission errors. The data link layer has two sublayers. One is the logical link control sublayer, which essentially maintains the communication link between two devices on the network. The other is the media access control sublayer, which manages the transmission of data between two devices. The network card on a PC has a MAC address, essentially a unique address for every device on a local area network. The data link layer ensures an initial connection has been set up, divides output data into data frames, and handles the acknowledgments from a receiver that the data arrived successfully. It also ensures incoming data has been received successfully by analyzing bit patterns at special places in the frames. If an error occurs, the data link layer notifies higher level protocols that something has happened to the physical link. Frame sequencing capabilities within the data link layer permit the receiving device to reorder frames that might have been transmitted out of a sequence. The data link layer verifies the packet is unimpaired. The data link layer also manages flows by enabling device on a link to detect congestion. Nearby devices then transmit congestion information so traffic can be rerouted accordingly. Physical layer. It defines electrical and physical specifications for devices. The physical layer defines the relationship between a device and a transmission medium, such as a copper or optical cable. This includes the layout of pins, voltages, cable specifications, hubs, repeaters, network adapters, host bus adapters, HBA used in storage area networks, and more. Physical layer in the OSI model plays the role of interacting with actual hardware and signaling mechanism. Physical layer is the only layer of OSI network model which actually deals with the physical connectivity of two different stations. This layer defines the hardware equipment, cabling, wiring, frequencies, pulses used to represent binary signal, and more. Physical layer provides its services to data link layer. Data link layer hands over frames to physical layer. Physical layer converts them to electrical pulses, which represent binary data. The binary data is then sent over the wired or wireless media.
The physical layer or layer 1 is the electrical physical layer of the model. This layer encompasses the network cables, power plugs, cable pinouts, wireless radio frequency, connectors, transceivers, receivers, repeaters, force of light, electric voltage, etc. When troubleshooting problems, this is typically the first place to start. Is the device plugged in? Is the wireless card working? At this layer, the model transmits the digital data bits from the source or sending device physical layer over network communication media, which can be electrical, mechanical, or radio, to the receiving or destination physical layer. The data link layer or layer 2 is considered the most complex of the layers. These layers is often divided into the sublayers called Media Access Control or MAC and Logical Link Control or LLC. These layers set up links across the physical network. When this layer receives data from the physical layer, it's checked for the transmission errors. and then package the bits into the data frame. From there, this layer manages the physical addressing method for the MAC or LLC layers. An example of MAC layer includes 802.11, wireless specification as well as the network layer or layer 3 handles the routing of the data. After the data arrives at this layer, each frame of data is examined to conclude if the data has reached its ultimate target. The layer sends data to the correct destination in outgoing transmission and receive incoming transmission as well. The IP portion of TCP or IP is the commonly known network layer for the Internet. This layer also manages the mapping between logical addresses and physical addresses for the IP addresses. This is accomplished through Address Resolution Protocol or ARP.
Transport. Transport layer provides communication between application processes running on different hosts within a layered architecture of protocols and other network components. In a nutshell, the transport layer collects message segments from applications and transmits them into the network. Here, the segments are assembled into fully fledged messages and passed on to layer 7. This layer enables the host to send and receive error-corrected data, packets or messages over a network, and is the network component that allows multiplexing. Transport layers work transparently within the layers above to deliver and receive data without errors. The send side breaks application messages into segments and passes them onto the network layer. The receiving side then resembles segments into messages and passes them into the application layer. Next is session. The session layer manages a session by initiating the opening and closing of session between end-user application processes. This layer also controls single or multiple connections for each end-user application and directly communicates with both the presentation and the transport layers. The services offered by the session layer are generally implemented in application environments using remote procedure calls. And then the sixth layer, presentation layer. The presentation layer is resembled for the following, or responsible for the following: the encryption, decryption, character string conversion, data compression, graphic handling. The presentation layer mainly translates data between the application layer and the network format. Data can be communicated in different formats via different sources. Thus, the presentation layer is responsible for integrating all formats into a standard format for efficient and effective communication. And then lastly, the seventh layer, application layer. In order to understand individual layers of the OSI model, it's important to know that this is much more of a framework than a concrete set of designation. Some experts describe that these abstract layers are being like a union where each layer protects the layers underneath it. And drilling down into the 7-layer model means peeling away each subsequent layer to look inside.